Hello students, I hope you all are fine. As you know that yesterday we were discussing about the method of preparation of alkanes. Okay, three methods we have already done. First one was from unsaturated hydrocarbon, means from alkene to alkane and alkyne to alkanes. Okay, after that we second method of preparation by Grignard reagent, then by Woods reaction. Okay, in Woods reaction, students, there was one limitation. Woods reaction we can proceed only for formation of the even number of the carbon, even number of the carbon containing alkanes. Why? Because if we take unsymmetrical alkyl halide, if we take unsymmetrical alkyl halide, means one we are taking methyl halide, second ethyl halide, like this. Okay, then we get three products there. Okay, three alkanes we form there, and all alkanes have similar boiling point. Clear? So they cannot be separated easily by fractional distillation. That's why we use Woods reaction for preparation of the symmetrical alkanes only. Okay. Then students, one more preparation method we will discuss today. That is the decarboxylation. That is the decarboxylation. Decarboxylation. By name we can do decarboxylation. D means removal. Removal of carboxylation means removal of carbon dioxide gas. Removal of carbon dioxide gas. Hydrogenation, addition of hydrogen. Dehydrogenation, removal of hydrogen. Hydrolysis, breakage of water. Okay, hydration, addition of water. Dehydration, removal of water. Okay, carboxylation, addition of carbon dioxide, and decarboxylation, removal of carbon dioxide. Okay, if you have carboxylic acid means RCOOH. Okay, if you react carboxylic acid with sodium hydroxide, then what will happen, students? We can remove water. And sodium carboxylate. Here this Na replace hydrogen plus formation of water take place. This is the sodium carboxylate. This is the ion, sodium carboxylate. Like if you have R group CH3, COONA, CH3COOH, this is the ethanoic acid. Okay, but if you have this one, then sodium ethanoate. In this way you will give name. Then sodium carboxylate. And if sodium carboxylate further heated with soda lime. What is the soda lime? Soda lime means mixture of sodium hydroxide and calcium oxide. When sodium hydroxide and calcium oxide both are mixed in ratio 3:1, then it is known as the soda lime. So when sodium carboxylate heated with soda lime at temperature 630 Kelvin. Simply you can give symbol this one also, because it is not easy to learn all temperatures. Okay, so simply you can give this symbol. Okay, but this temperature range is 630. Then student, what will happen? Decarboxylation means removal of carbon dioxide. So where carbon dioxide present in this? Here. Here simply we can write. Then what will happen? From here, this one, removal of this take place. You can see this is Na, 2Na, Na2C, 1, 2 and 1 this oxygen, CO3. CO3. Okay, so you can remove sodium carbonate. Then what left? RH, and RH is alkane. In this way, simply you can form alkanes. Okay, like this. If you have sodium ethanoate, react this with soda lime. Soda lime means sodium hydroxide and calcium oxide in ratio 3:1, heated at temperature 630. Simply you can remove this one, Na2CO3 means sodium carbonate. You know very well, na? Sodium carbonate gives us CO2. So indirectly we are removing carbon dioxide. Then CH3 and H. What is this? This is methane, CH4, methane. Here one carbon less compound you are getting. Here you are having ethanoate, 2 carbons. One carbon is removing as carbon dioxide there. Okay, and as product you are getting methane, not ethane you are getting here methane. Okay, means one carbon less product you are getting here. But in Woods reaction, you are getting extended product. Clear? Here degradation take place in decarboxylation. Okay, students. So 4 or 5 methods we have done today. Now we will discuss about some chemical properties. Today we will discuss about the substitution reaction. Substitution reaction is the chemical property of alkane. Chemical property. Now you know very well, in method of preparation, our product was alkane. In method of preparation. But now we are discussing about the chemical property. In chemical property, our reactant will be alkane. Clear or not? So today we will discuss about one chemical reaction of alkane, that is the substitution reaction. And students, same reaction as it is, same reaction you will study in 12th class in haloalkane. In method of preparation of haloalkane, you will discuss same reaction, that is the substitution reaction. Okay, substitution reaction. Here, chemical property of alkane means one alkane you will have as reactant. Okay, you will react this alkane with other compounds. You will react. So students, in substitution reactions, we can say halogenation also, because we will replace one or more hydrogens by halogens. One or more hydrogen by halogens. Halogens are fluorine, chlorine, bromine, iodine. Iodine. Okay, here if we will see order of the reactivity, then fluorine, due to its small size, it is more reactive. This is the high explosive. Okay, and reactivity of iodine is less here. Clear or not? This is the reactivity order of halogens. What will happen? If you have any alkane, let us consider you want to do chlorination. You want to do chlorination. Means your halogen is chlorine. Okay. Then students, what will happen? This reaction you will proceed in presence of sunlight. In presence of sunlight. Okay. Then this is methane and this is chlorine. Simply one hydrogen you can replace with chlorine. Simply what we are doing, we are replacing one hydrogen by chlorine. So at place of one hydrogen, now only three hydrogens, and at place of this chlorine, from here HCl you will remove. But students, if you are having this Cl2 in excess, then what will happen? Further second molecule of chlorine can react with this one. Then one more hydrogen can be replaced. So CH2, Cl2 plus HCl. Clear? One more unit can react. Then one more hydrogen, CH only, can replace by chlorine. You can get CHCl3. One more can replace at place of this also chlorine. Clear? Students, this reaction we will not use for preparation, or here we are discussing about the chemical properties, but in method of preparation of haloalkanes, we cannot use this reaction for preparation of haloalkanes in laboratory. In laboratory. Why do we not use? Because here we get mixture of haloalkanes. We are getting mixture of haloalkanes. We are getting chloromethane, dichloromethane, trichloromethane. This is also known as chloroform, and tetrachloromethane. Okay, and all are having similar boiling points. Okay, it is difficult to separate them by fractional distillation also. That's why we do not use this method for preparation of haloalkanes in laboratory. At industrial purpose, we can use this reaction. Okay, here we are getting mixture. That's why we do not use. Then what will be mechanism of this reaction? What will be mechanism? How does it proceed? We will see. Okay. You know, student, this reaction shows the free radical mechanism. Free radical mechanism. You are having methane. First of all, simply we can write only one step we are doing. We are having methane. When we will do chlorination in presence of sunlight, then one hydrogen replaced by chlorine plus HCl. We will write mechanism for this one. This is substrate, this is attacking reagent. Okay, these are the conditions and these are the products. So students, reagent, why do we use reagent? Because reagent help to proceed reaction. Here this chlorine in presence of sunlight, you know very well, simply in presence of presence of sunlight, homolytic cleavage take place. Then students, in homolytic cleavage, free radical formation take place. This bond will break. One electron goes with this one and one electron goes with this one. Okay, then Cl free radical plus Cl free radical form. Here formation of free radical take place. Okay, and this is known as the initiation. फ्री रेडिकल मैकेनिज्म स्टूडेंट्स हमारा 3 स्टेप्स में होता है. वन इज द इनिशिएशन, देन प्रोपोगेशन, देन टर्मिनेशन. इनिशिएशन में क्या होगा कि जो हमारा कि रिएक्शन को स्टार्टअप कहाँ से मिलेगा, ओके. प्रोपोगेशन में हमारे डिफरेंट जो जितने मैक्सिमम फ्री रेडिकल्स हम बना सकते हैं वो बनाएंगे और अपने फाइनल प्रोडक्ट तक हम क्या करेंगे, रीच करेंगे. एंड टर्मिनेशन में जितने भी हमारे फ्री रेडिकल्स बने हैं उनको टर्मिनेट करके उनसे हम स्टेबल स्पीशीज की फॉर्मेशन करेंगे. सो देयर आर 3 स्टेप. फर्स्ट इज द इनिशिएशन. इनिशिएशन में जब तक ये क्लोरीन स्टेबल है तो तब तक तो रिएक्शन होगी ही नहीं. जब तक कोई अनस्टेबल होगा तभी तो दूसरे के साथ रिएक्ट करेगा. ओके, सो पहले क्या हुआ, हमारे पास ये क्लोरीन था, हमने इसको फॉर्म करना है तो क्लोरीन, दिस विल ब्रेक इन प्रेजेंस ऑफ सनलाइट, homolytic cleavage take place and formation of free radical take place here. And you know very well, free radical is highly reactive species. It is intermediate. Okay, then what will happen? Propagation means more number of free radical will form in second step. इनिशिएट तो हमारी हो गई, हमें फ्री रेडिकल मिलना था, मिल गया. ओके, अभी प्रोपोगेट. अभी ये हाईली रिएक्टिव स्पीसीज हैं, तो ये क्या करेंगे, किसी दूसरे के साथ मिलके इलेक्ट्रॉन्स इनको कहां से मिलेंगे, तो ये अटैक करेगी किस पर, इस मीथेन पर. इस पर अटैक करेगा, मीथेन पर. मीथेन CH4 plus this free radical because this is highly unstable. Then students, it will break this one. ये इसको break कराएगा. Clear? Then what will happen? CH3 free radical, one electron taken by this one, and from here H free radical. Clear or not? Then what will happen? CH3 free radical plus this H free radical and Cl free radical, because इसको तो स्टेबल होना है इसलिए तो इसने इसके साथ रिएक्शन की है. Then H free radical and Cl free radical can form bond between them and they can form hydrogen chloride. It is clear to you or not? Yes. You know, इस क्लोरीन फ्री रेडिकल ने रिएक्ट किया किसके साथ, इसके साथ. अब क्या है, अब ये रिएक्टिव स्पीसीज है हमारे पास, ये अनस्टेबल है. ओके, अब ये बेचारी पहले से ही एंग्री है, दिस इज वेरी एंग्री. तो ये क्या करेगा, इस क्लोरीन ने इसे परेशान किया था, सो फर्दर ये क्लोरीन के ही दूसरे, क्लोरीन ने इसे परेशान किया, ये बेचारा क्या था, स्टेबल था, इधर स्टेबल था। तो इस क्लोरीन फ्री रेडिकल ने क्या किया, इसको इसके साथ रिएक्ट किया और इसको क्या बना दिया, अनस्टेबल स्पीसीज। तो फर्दर ये क्या करेगा, इसकी दूसरे यूनिट के साथ में रिएक्शन करेगा, इसको ब्रेक करेगा। क्लियर? देन व्हाट विल हैपन, इट विल ब्रेक दिस वन, it will break this one. Then from here Cl free radical formation take place. Then this CH3 free radical and Cl free radical, they can form bond between them. Then formation of CH3Cl, formation of CH3Cl plus 1 Cl free radical, दोबारा से इसने क्या किया, इसको अनस्टेबल स्पीसीज बना दिया। फर्दर क्या हुआ, अनस्टेबल स्पीसीज हो। बट हमारे पास एक गुड थिंग क्या है, हमें प्रोडक्ट क्या चाहिए था, CH3Cl। हम अपने प्रोडक्ट तक पहुंच गए, अब हमने इनको रिएक्शन नहीं करवानी। क्लियर है? सो फाइनली वी विल टर्मिनेट। टर्मिनेट मीन्स जितने मैक्सिमम आपके पास फ्री रेडिकल्स बने हैं उनको आपस में रिएक्ट करेंगे और हम क्या करेंगे, रिएक्शन को क्या कर देंगे, टर्मिनेट कर देंगे। सो इन फाइनल टर्मिनेशन फ्री रेडिकल आपके पास क्या क्या बने थे, Cl फ्री रेडिकल बना था। सो Cl फ्री रेडिकल बट रिएक्शन मिक्सर्स में सभी हैं, ऑल आर अवेलेबल इन रिएक्शन मिक्सचर, सो दे कैन आल्सो रिएक्ट विद ईच अदर बिकॉज हाईली रिएक्टिव स्पीसीज दीज आर, ओके, बिकॉज दे आर द हाईली अनस्टेबल। क्लियर? देन दे कैन आल्सो रिएक्ट विद ईच अदर, chlorine gas can be produced, some amount of chlorine gas can be produced in reaction mixture, okay. Some CH3 free radical and chlorine free radical can also react with each other, chloromethane also, and CH3 free radicals can react with each other also, yes or not? Okay, then CH3 ethane can also form. You know students, कई बार कॉम्पिटिटिव एग्जाम्स में क्वेश्चन पूछा जाता है कि ड्यूरिंग दिस रिएक्शन, ड्यूरिंग हैलोजिनेशन ऑफ एल्केन, ओके, what hidden product we get during reaction. We are saying here we are getting only alkyl halide and hydrogen halide, okay, we are not getting methane, we are not getting ethane. But students, when we will discuss about the mechanism, we will see mechanism of this reaction, then as a hidden product we are getting ethane, okay. ऑप्शंस में हमारे वाटर, क्लोरोमीथेन, इथेन, ओके। सो यहाँ पर ये एक हिडन प्रोडक्ट बनता है ड्यूरिंग दिस रिएक्शन, और यहाँ से क्वेश्चन पूछा जाता है, आपके बोर्ड लेवल पर नहीं बट कंपटीशन लेवल में कई बार ये क्वेश्चन पूछा जाता है। दिस वन इज द हिडन प्रोडक्ट ऑफ दिस रिएक्शन, क्लियर और नॉट? सो व्हाई इट इज नोन एज द सब्स्टिट्यूशन बिकॉज वन हाइड्रोजन रिप्लेस्ड बाय हैलोजन, ओके, दैट्स व्हाई इट इज नोन एज द substitution reaction. This reaction follow free radical mechanism. Free radical mechanism can be proceed in 3 steps. First one is initiation. Initiation जहां पर free radical की production होगी, only production of free radical, कि जो free radical production के बाद free radical हमारा unstable species है जिससे वो आगे react करेगा, clear? Then प्रोपोगेशन में क्या होगा, मोर नंबर ऑफ फ्री रेडिकल्स वी विल फॉर्म, जितने मैक्सिमम बन सकते हैं वी विल फॉर्म एंड वी विल रीच एट आवर डिजायरेबल प्रोडक्ट आल्सो, क्लियर और नॉट? आफ्टर दिस टर्मिनेशन, टर्मिनेशन में जितने भी फ्री रेडिकल्स बने थे उनको आपस में रिएक्ट करेंगे और हमें जितने मैक्सिमम प्रोडक्ट, हिडन प्रोडक्ट या फिर जो भी आपके मेन प्रोडक्ट्स हैं जितने मिलेंगे उतना हम लिखेंगे। क्लियर? बट स्टूडेंट दिस रिएक्शन also have limitation. You know, if we want to form chlorination, you have done. But students, if you want to do fluorination, instead of chlorine, if you are having fluorine gas here, and then you want to do this reaction, then student, we will not proceed this one. Why? Because what is the reactivity order? Fluorine is the most reactive. Clear or not? So because fluorine is most reactive, that's why it gives highly explosive reaction. Beta, highly explosive जो रिएक्शन हमारी है ड्यू टू more reactivity of the fluorine, this reaction is very explosive reaction. Okay, so we do not use this method for preparation of the fluoroalkane. Okay, bromination we can do. Bromination, yes Karan, your attention should be here only. Bromination we can do simply. Iodination we also do not do. Iodination, if you want to do iodination, means if you are having iodine, then what will happen? Here iodomethane plus 1H and 1I, hydrogen iodide form. Students, this reaction is reversible. This reaction is the reversible reaction. Why it is the reversible reaction? Because this hydrogen iodide is strong reducing agent. This one is the strong reducing agent. Reducing agent which reduce other and oxidize itself. Okay, this Hi can be further converted into the iodine very easily. Its oxidation take place, removal of hydrogen, H oxidation. That's why it is reducing agent here. Here, this hydrogen iodide is strong reducing agent. That's why it can be further converted into iodine very easily. Clear or not? Yes. And we do not get best yield of this. That's why we do not use this method for preparation of the haloalkane, students. If we want to proceed this one, then we will do this reaction in presence of the strong oxidizing agent. Like in presence of concentrated HNO3 or iodic acid HiO3 we can take. Okay, then we can form. So iodination we do in presence of the strong oxidizing agent. यहाँ स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट लेंगे जो रिएक्शन को रिवर्स ना होने दे, क्लियर और नॉट? सो स्टूडेंट, सब्स्टिट्यूशन रिएक्शंस को हमने देखा। सब्स्टिट्यूशन रिएक्शन में हैलोजिनेशन, यहाँ पर हम फ्लोरिनेशन नहीं करवाते। क्यों नहीं करवाते? क्योंकि हाईली एक्सप्लोजिव रिएक्शन है। आयोडीनेशन अगर हमने करवाना है तो हम किसकी प्रेजेंस में करवाएंगे? स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट की प्रेजेंस में करवाएंगे। ऐसा क्यों? क्योंकि जो HI की फॉर्मेशन हुई थी ड्यूरिंग रिएक्शन, तो HI हमारा एक स्ट्रॉन्ग रिड्यूसिंग एजेंट है, जिससे ये दोबारा से किस में कन्वर्ट हो जाता है? आयोडीन में। तो रिएक्शन हमारी क्या है? एक रिवर्सिबल रिएक्शन है, जिसकी वजह से हमें जो बेस्ट यील्ड है आयोडो मीथेन एल्केन की, वो हमें नहीं मिल पाती, क्योंकि ये दोबारा से एल्केन में कन्वर्ट हो जाता है इसकी वजह से। ओके, तो इससे हम क्या करेंगे? लीच-एटिडियल प्रिंसिपल अभी तक डिस्कस नहीं किया है, इक्विलिब्रियम रिएक्शन में करेंगे। तो रिएक्शन को हमने फॉरवर्ड डायरेक्शन में प्रोसीड करने के लिए हम यहाँ क्या यूज करेंगे? एक स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट का यूज करेंगे। सो एनी डाउट इन सब्स्टिट्यूशन रिएक्शन? Okay, so thank you. Have a nice day.